we
Okay,
denote
sir.
it as L, M, and N. And in vector, we have already studied an important relation. Do you remember that? It
Uh,
is L square plus
plus
M
m square
square
plus n
plus
square
N square
equals to,
equals to 1.
yes, sir.
Okay, this is the important relation that we have already studied.
Yes, sir.
And the direction ratio, suppose we take this point, okay, perpendicular drawn from P to the x-axis, then it is the coordinate of it will be a comma 0 comma 0. This
Yes,
a
sir.
is a, and here let's say 0 b0, and here let's say if we draw perpendicular to z-axis, it's difficult to draw perpendicular to z-axis on plain paper. So let's consider we have drawn perpendicular over here. This will be 0 comma 0 comma c. So a b c are actually the direction ratios. It is called
Directional
direction
ratios.
ratios.
Yes, sir.
And if a line passing through, we have already discussed these things in the
Yes, sir.
previous.
We have.
Yes, we discussed these things in the previous class. So direction ratios, we have a relationship in direction cosine and direction ratios. They are proportional to each other. Direction ratios and cosines are proportional to each other. Also, if we have been given direction ratios, then we can find direction cosines. Suppose we have direction vector. Let's say direction vector B is AI cap plus BJ cap plus CK cap. Let's say something else. D, direction vector D is AI cap plus BJ cap plus CK cap. Then direction cosine will be, direction cosine can be obtained by dividing by
The a
magnitude of
square plus
D.
b square. Yes, sir.
Magnitude of, yes, magnitude of D. So direction cosine DCs will be, this is magnitude of D. So direction cosine will be
A by n root
root
a square
A
plus b
square
square
plus B square plus C square. This is the
plus b.
unit vector. Okay, we find the unit vector.
Yes, sir.
And coefficient of ijk will be direction cosines. So DCs will be A over root A square plus B square plus C square, B over root over A square plus B square plus C square, and C over root over A square plus B square plus C square.
Yes, sir.
And
Got it.
also we have a relation between direction cosine and direction ratios, that they are proportional to each other. How they are proportional? If we take cos alpha, can you tell me what will be the cos alpha? This is R,
A
this is A, this distance
is,
is A,
yes, sir. A
okay?
commas will
A
be
over R. Cos
yes,
alpha will be
A
A over R,
R.
isn't it?
Yes, sir. It will
Yeah,
be
based upon hypotenuse. If we take this OAP, triangle OAP,
P. Okay.
if we take triangle OAP, This is alpha, this is A, this distance, okay?
Yes, sir.
And this is R. So cosine alpha, cos alpha is A over R. In the similar way, cos beta equals to B over R, and cos gamma will be C over R.
T over R.
Cos alpha is actually nothing but L. We denote it as L, and B over R, cos beta
M.
M, cos
And
gamma M.
M. Yes, sir.
So we can see that A over L equals to B over M equals to C over N equals to R
Yes, sir.
by cross multiplying. A over L equals to R, A over M equals to R, B over M equals to R, C over N equals to R.
Yeah. Yes, sir.
That means the ratio is constant. Ratio remains the same.
Yes, sir.
So direction cosines, where we can conclude that direction cosine DC's and DR's direction ratios are proportional to each other. This is the important relation that has to be noted down.
Got it, sir.
So DC's and DR's are proportional to each other.
Take it.
Now coming to the DRs again. Suppose we have a point A x1 comma y1 comma z1 and B point x2 comma y2 comma z2. Then DRs of line AB, joining AB. DRs of AB will be x2 minus x1, y2 minus y1, and z2 minus
Z2 minus Z1. Yes, sir.
yes, and z2 minus z1. Now coming to the line in a plane. Line in a plane. Equation of line, equation of a line can be determined if a point and direction vector and direction, we discussed all these things. So I'm just
It's
begin.
just revising.
Yes, yes. This is all recap. A point and direction vector. So R vector equals to A plus lambda times B vector. In vector form, it is vector form. In Cartesian form, we have x minus x1 over A, y minus y1 over B, and z minus z1 over C, where x1, y1, z1 is the point and A, B, C are direction ratios. Okay.
Yes,
And
sir.
second, if we have been given 2 points, if 2 points are given, 2 points are given through which line passes, through which the line passes. Then we can determine the equation of line. So suppose 2 points we have been given, x1, y1, z1, 1 point. And second point we have been given x2, y2, z2. Then we have in Cartesian form x minus x1 over x2 minus x1, y minus y1 over y2 minus y1, z minus z1 over z2 minus z1. This is the equation of line in Cartesian form. In Cartesian form.
Yes, sir.
And in vector form, r vector equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times x2 minus x1, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap.
Got it, sir.
This is vector form.
So in the Cartesian form, x is just a variable, sir.
X, Y, Z are variable.
Okay, it's because we only have x1 and x2.
Yes,
then-
x1, y1, z1, the x2, y2, z2, these are the coordinates of the points.
Okay, got it.
So now angle between two lines, angle between two lines. So suppose we have been given two lines. One is line, suppose line one is r vector equals to a1 plus lambda times b1. Okay.
Yes, sir.
And line 2 is r vector equals to a2 plus lambda times b2. Then angle between these two lines, angle between these two lines, between the lines will be
Yes, sir.
b1 dot b2 divided by magnitude of it. This is nothing else we have already done in vector. Okay.
Yes, sir.
So, but make sure we are taking just direction vector, not the point. A1, A2
Oh,
are
okay.
position vectors. A1,
I
A2.
didn't understand that, sir. Sorry.
In Cartesian form, in Cartesian we take cos theta equals to A1, A2 plus B1, B2 plus C1, C2 over root over A1 square plus B1 square plus C1 square, A2 square plus B2 square plus C2 square.
Yes, sir.
Okay. So these A1, A2, B1, B2, C1, C2, A1, B1, C1, A2, B2, C2 are actually nothing but direction ratios. These are direction ratios.
Got it, sir.
So this is direction ratios. Now if theta is 90 degree, if theta is 90 degree, that means if
Cos 90.
both the lines are perpendicular to each
Each other.
other, L1
Yes.
perpendicular to L2, then in that case, cos 90 is what? What is cos 90? It is 0.
0.
Okay. That
Yes, sir.
means B1 dot B2 will be 0.
0. Yes, sir.
That means that is in Cartesian form A1 A2 plus B1 B2 plus C1 C2 will be
0.
0.
Yes, sir.
Okay. Now
Yeah.
to convert equation of line from Cartesian form to vector form and vice versa, vice versa. Suppose we have been given x minus x1 over a equals to y minus y1 over b equals to z minus z1 over c. This is the equation of line in Cartesian form. This is
Yes, sir.
equation of line.
In a Cartesian form.
Yes, equation of line in Cartesian form, and we need to convert it into vector form. So what we do, we take lambda, okay,
Yes, sir.
and r vector is always taken as xi cap plus yj cap plus zk cap. Okay, r vector is always xi cap plus yj cap plus zk cap. Now, from this equation, we have x equals to x1 plus a lambda, isn't it? A lambda
LM.
plus x1. Do you understand?
Then what about A, sir?
A lambda plus
Oh, A lambda
x1
plus N. Okay.
cross multiplication.
Yes, sir. Got it.
A lambda plus x1.
Yes, sir. Got it.
So x equals to x1 plus a lambda. Y equals to y1 plus b lambda.
Yes, sir.
And z equals to
Z1
z1 plus c lambda.
C lambda.
If we just put the value of x, y, z in first, then we have r equals to x1 I cap plus y1 j cap plus z1 k cap plus lambda times a I cap plus bj cap plus ck cap.
Yes, sir.
This will be the vector equation. Now I am going to give you the simple approach to convert Cartesian form into vector form. Very simple.
Got it, sir.
No need to think of all these things. Okay, just take these three things. Okay, first write r vector. Okay, then just take these three things and change their sign. If it is negative, then take positive. If it
it's
is positive, then take negative.
Okay, sir.
Okay, so this will be r vector equals to negative signs are there.
Yes, sir.
Negative, negative, negative. So make
So-
it positive
X1
and
plus
take
Y1
y1 j cap
J cap.
plus z1 k cap.
K cap.
Take lambda plus lambda, and then whatever in the denominator is there, ABC, take AI cap plus BJ cap plus CK cap. As
Oh,
simple
okay.
as that.
Yeah, so that's very simple.
And if we have vector form like R vector equals to AI cap plus BJ cap plus CK cap. And
Yes.
we wish to convert in plus lambda times. Oh,
Plus lambda.
just a minute, just a minute. Position vector x1 I cap plus y1 j cap plus z1 k cap. This is the position vector.
Okay.
Okay, plus lambda times direction vector. This is called direction vector. Then what we do? We pick up these points x1, y1, z1. We take the coefficient of position vector,
Okay.
okay, and
Okay.
make it x minus x1, y minus y1,
Z minus Z.
z minus z1. Okay, make
Yep.
equal sign
Yes, sir.
and take the coefficient of direction vector. Take the coefficient of direction vector in the denominator.
So DC.
That's it. Your
So
job is done.
basically, you have to check what the sign is and then put it into place properly.
Yeah, whatever the sign is there, take it x minus that.
Okay, sir, got it.
So this is how we convert vector into Cartesian and Cartesian into vector form.
Yes, sir, got it.
And now the last thing that we are going to discuss is shortest distance between two lines. The most important thing. One question of either 5 marks or 3 marks is being asked in each and every year.
Oh,
And not only in academic exams, it is being asked in even in the most prestigious examination of India globally,
oh,
that is IIT JEE.
oh, okay.
Shortest distance between two lines.
Yep.
Shortest distance between two lines. So let us suppose we have equation of two lines. Equation of two lines. Let's say first equation is r vector line 1, r vector equals to a1 plus lambda times b1 vector. And second line is r vector equals to a2 plus mu b2. Lambda mu are constant.
Okay.
So shortest distance, the formula for shortest distance is SD equals to b1 cross b2 dot product with a2 minus a1 divided by b1 cross b2 magnitude of it and whole thing in modulus. This is the formula. Just you need to put all these things into the formula and get the value. Okay.
Okay.
If the equations of line are given in Cartesian form, then you can convert it into vector first, then put into the formula. However, we have formula in Cartesian form as well, but that is a little bit difficult and lengthy.
Okay.
So better you convert it into vector form and then put into the formula.
Got it, sir.
Plug into the formula, right?
Yes, sir.
So now giving 1 minute time to arrange all these things, turn over the page of book and all. Just a minute.
So could you just go back one time to that page again?
Okay, okay, just a minute. Just a minute. You want to note it down, right?
Yes, I want to note it down.
Okay. I'm sending you. Don't worry.
Okay, sir.
I'm going to change the.
Got it, sir.
But you understood. I just recap once again so that you can just go through it.
Yes,
Okay. So exercise 11.1. Question 1 we did. We have been given line makes 90 degree, 135 degree, and 45 degree with x, y, z axis. And we have to find direction cosine. Direction cosines are nothing but cosine of angle found by the line with x, y, and z axis. So cos 90, cos 135, cos 45, we got these values. Cos 135 is -1 over root. In the second question, we have been given that direction angles made by the line are equal with x, y, z axis. So angle, cosine of angle, okay, cosine of angle with x axis, cosine of angle with y axis, and cosine of angle with z axis are cos alpha, cos beta, cos gamma. That are denoted by LMN, and these three are equals. We have well-known relation. We also used in vector.
Okay.
So LMN are equal. So this will be 3L square equals to 1, and L is plus minus 1 over root 3. M equals to plus minus 1 over root 3. N equals to plus minus 1 over root 3. In the third question, we have drs of line given. We need to find the DCs. So we know that we have to find the magnitude and divide it. This will be the DCs. And in question 4, A, B, C, 3 points are given, and we have to show that these are collinear. So what we do, we find DRs of AB. DRs of AB is B minus A, minus 1 minus 2, minus 2 minus 3, 1 plus 1 minus 4. And similarly, we found the DR of BC. And we see that they are proportional to each other. If we take the ratios, corresponding ratios, minus 3 over 6, minus 5 over 10, minus 3 over 6, they are in the same proportion. That means ABC are collinear. Okay. And in question 5, we have been given the vertices of the triangle ABC. So we got the side vector, AB vector, BC vector, and CA vector. Their DRs are, we got the DRs of these sides.
Yeah.
Okay. And then we know how to find the direction cosine. We need to find the direction cosine of each of the sides. So we will just divide by the magnitude of it, magnitude of direction vector. Okay. Now we are doing exercise 11.2. In first question, we have been given 3 sets of direction cosines, and we have to show that these lines are perpendicular to each other. If the lines are perpendicular, then sum of the product of direction cosine, like L1 L2 plus M1 M2 plus N1 N2, this should be equal to 0.
Yes, sir.
We have just taken one pair of sets. The rest of the work you have to do at home. You can take another pair. 3 pairs will be there.
Okay.
For line 1 and line 2, we have done. Now you have to do for line 2 and line 3 and line 1 and line 3.
Yeah.
These 3 pairs. And in question 2, we have been given ABC 2 pairs of direction, 2 pairs of points. Okay, 2 points AB and another 2 points CD. And we have to show that they lines through these points are perpendicular to each other. So we got the DRs of AB, now DRs of CD. DRs of CD will be 1 plus 1, 2, 2 plus 2, 4, and 5 minus 1, 4.
Right.
Now, if they are perpendicular, then it should be A1, A2 plus B1, B2 plus C1, C2 should be equal to 0. Let's check it. 2 into 2 plus 5 into 4 minus 4 into 4.
Yes, sir.
3 minus 1, 4 plus 1, minus 2 minus 2. 1 plus 1, 2 plus 2, 5 minus 1. Okay. So I think we have taken some point wrongly. 1 minus 1, 2. Okay. 3, 4 minus 2. 3, 4 minus 2 and 0. Okay, we have taken G.
C. Wait, is C and D correct, sir?
No. We
Point
have taken
C.
from third question.
Yes,
We
sir.
have
Point
taken from
C.
third question. These pairs we have taken from
First, that's what,
third
sir.
question.
Third question, though,
Yes.
sir. The points are 0, 3, 2,
0, 3, 2 and
3, 5, 6.
3, 5, 6.
Yes, sir.
So DRs of CD will be 3 minus 0, 5 minus 3,
2.
and 6 minus 2,
Sir.
4. Okay, A1, A2 plus B1, B2 plus C1, C2 will be 2 times 3 plus 5 times 2 minus 4 times 4. So this is 6 plus 10 minus
16.
16.
0.
16 minus 16 is 0. Therefore, lines are perpendicular to each other.
Yes, sir.
Lines are perpendicular to each other. Question number 3 is almost the same.
Parallel.
Parallel, you have to take the ratio. Ratio will be equal. Okay.
Okay.
So I'm just giving the hint to you. Lines are parallel if A1 over A2, B1 over B2 equals to C1 over C2.
C2.
Find the equation of line which passes through the point 1 to 3 and parallel to this. This is very simple. Equation of line passing through point to find equation of line passes through one, two, three, and parallel to vector 3i plus 2j minus 2k. This is very simple.
Yeah.
So we have been given a vector, that is I plus 2j plus 3k, position vector. And we have been given b vector 3i plus 2j minus 2k. This is point and this is direction. Okay.
Yes.
This is direction. And this is point. 1, 2, 3 is point. Equation of line will be r vector equals to, we always take r vector in the equation, equals to, it is compulsory,
Yes.
a vector plus lambda times b vector. So I plus 2j plus 3k plus lambda and put the vector lambda b.
3 2k plus 2k.
That's it. This will be the answer.
Okay.
Question number 5. Oh, okay. It was 5 in fact. Question number 6.